All right, so now that you have a little bit of Gaussian elimination using a TI under your belt, we're going to introduce one more technique, which is pretty much, it's kind of piggybacking on the Gaussian elimination method. We're using the Gauss-Jordan method to solve this system of equations. And one thing with the Gauss-Jordan method, how is it different than Gaussian elimination? Well, technically it all is lumped into one subject of being Gaussian elimination. But more precisely, Gauss-Jordan method takes your augmented matrix which is, let's see, let's write that out while we can. 1, -2, 4, and 6. 1, 1, 13, 6. 2, -6, 1, and 10. So the Gauss-Jordan method takes the augmented matrix and it turns it into reduced row echelon form. And if you remember from some of our previous practice, if something's in reduced row echelon form, remember we have that diagonal of ones. Just like, oh, excuse me. See what happens when I multitask. Here we go. We have that diagonal of ones. There we go. A lower left triangle of zeros, just like row echelon form, but more importantly, an upper right triangle of zeros. So what happens is these end up being our solutions once we get what those numbers are. So that's the idea, is to turn your augmented matrix into a matrix that is the equivalent reduced row echelon form. And you probably guessed it. Yes, we could do this by hand for maybe future classes, but the TI also has this capability. So this is my favorite method of them all when you see this chapter. So let's go to our TI. And I believe we have this entered in from a previous example, but let's just double check. Let me go, if we're going to remember how we edit matrices. So remember it's second X inverse, or second matrix. And I'm going to go over to edit just to make sure nothing changed. So again, we still have the 3x4 matrix. We are still looking at, it's the same system, I believe, from one of our previous examples. So we do have 1, -2, 4, 6, 1, 1, 13, 6. 2, -6, 1, and 10. So if this was a different system, all you have to do is edit the entries inside. So I'm feeling pretty good about this. Let's go back to the home screen, second mode to quit out. And if you're interested, what we're going to do is kind of the same thing as row echelon form. If you press, again, second X inverse to call up the matrix menu, we're going to scroll over with the right arrow key once. And we're going to use the down arrow key to find out where reduced row echelon form is. And we see row echelon form is item number A, and right underneath item number B, if you'd like to call that up instead of using the down arrow key, we have RREF standing for, you guessed it, reduced row echelon form. So the only thing we'd have to do at this point is call up the matrix that we have entered. So again, we do that with second X inverse. And this time we already have the name, that's A, that's item number 1. I close the parentheses. I press enter and check it out. This is so exciting. Look, the answers are right in front of us. So this is super nice. Let's copy that over just so that we could see it and verify. We'll go over to our paper one more time. And you'll notice, I don't think I can paste it on top, but I will paste it to the side so we can all see together. There we go. I'd just like to make this a little bit larger for us. And will it go on top? Oh, it will. Look how much it surprises me sometimes. Love this technology. Okay. So again, if you kind of recognize, we have that diagonal of ones, a lower left triangle of zeros, upper right triangle of zeros, and now we have our solutions right away. Now just be careful with the solutions, our solution. Remember that the way your matrix is orientated is that you do have x equals negative 14. That's where that leading one is. The second row, the leading one is in the y position, so it's y equals negative 6. And then the third row, the leading one is in the z position, so that's z equals 2. So if we were to write this as an ordered triple, we would see negative 14, negative 6, and 2. So that is the quickest way to solve this linear system of equations. At least with, if you have the TI on hand, it's really, really nice. I also recommend if you end up having to solve larger system of equations, 4x4 or 5x5, I don't think they're going to make you do anything like this in college algebra, but maybe a little bit in your future math classes. If you do have the capabilities of your TI, it is not that hard to enter in your matrices, and then turning it into reduced row echelon form automatically guarantees you an answer. So I hope you're as excited as I am about this technique, because it just gives you a very, very nice way to solve the system of equations without a lot of writing or paperwork. I really hope this helps, and I hope that you're excited to move on to the next section to learn another trick about solving matrices. So I will see you then.